So what do you understand by learning by discovery? As the name is showing you the discovery, what do you understand by the discovery or learning by the discovery? What do you understand by this? क्या कोई discuss कर सकता है learning by discovery? In general form, if we talk about learning by discovery or learning discovery, what you do as a student-centered approach where the learner actively explore and acquire knowledge through the direct experiences. Whatever the experience he had generated in the past through the direct experiences, investigation, and the problem solving. So, what main things we are considering here? Learning through the direct experiences, investigation, and the problem solving, fostering the critical thinking and the creativity. And under the AI also we are talking about here the learning by discovery. So what can be the what should be known before what should be known at the system when we are talking about learning by discovery? Some active knowledge should be there, right? On based on which the inquiry can be done. The discovery learning can entail asking the questions, investigating, then experimenting the uncovered knowledge and the solutions. Problem solving can be there with the minimum teacher guidance. So the first word here we are talking about an entity acquire knowledge without the help of a teacher. Nobody is teaching here. So in the AI, in the artificial intelligence agent, where we are implementing the learning by discovery, we are talking about the system will learn by its own experiences. Somewhere we are talking about here the neural networks also, right? So what we will discuss here, whether the pure discovery will be there or the guided discovery will be there, right? So learning by discovery is typically a learning system where a system or where a AI agent or an intelligent agent actively explore. The system will explore now and infer a new knowledge from the data without the explicit instructions. Means no programmer is here to coding or giving the instructions here or the labeled examples. And no examples are there, no external instructions are there. The system will explore the data, will explore the active knowledge and generate a new knowledge from that data. So as the discovery word is here, so scientific discovery is the application here, you can say that, and various AI model is there to use, which can use to generate a hypothesis in the learning by the explanation. Also, we have talked about the hypothesis, or it can uncover the hidden patterns in the complex data types. So what is basically learning by discovery? We are talking about the system should be actively or proactively explore the data. The system should be able to actively explore the data, right? So our system can explore the different patterns from the complex data sets. It can search for the different patterns and the relationship between that patterns or the data. And we have when we have started the learning, we have talked about the machine learning, and in the machine learning we have talked about the supervised learning, unsupervised learning, and the reinforcement learning. And that also we are talking about the unsupervised learning should be able to done by the AI agent or the intelligent agent, where we are talking about learning by the discovery. What do you understand by the unsupervised learning? Which rely on the when the system learn from the unlabeled data, when the data is not properly labeled without the external instructor here. So it will generate a new knowledge or the new insights or the concepts or the theories from the data that is already present in the system or from the existing knowledge or the existing knowledge base. So it will be definitely when we are talking about discovering the new data or the new patterns, we are talking about here this field or this learning by discovery is particularly applicable in the scientific discovery, drug discovery, and even in the areas like the content recommendation and the intelligent search. So various discovery systems are there which are working automatically to identify the new scientific concept or the law. Unsupervised further string is there, generative adversarial networks are there, and the reinforcement learning has been improved. So what do you understand by here the AM program? First, we are talking about here the history and the discovery. The theory-driven discovery is the AM program, which was there in the 1976. The AM is a program that discovered the concepts in the elementary mathematics and the set theory. So here we are talking about the elementary mathematics, and the AM has two inputs here: a description of some concepts of a set theory, right? What we are talking about the LISP. What do you understand by the LISP? This is the programming languages or family of the programming languages that have a strong historical connection, right? So uh, here we are talking about the set union, intersection, the empty sets here, information on how to perform the mathematics, examples of functions here. So these two inputs should be there under the learning by discovery. So AM employs many general purpose AI techniques. What AI techniques it is imposed or employs a frame-based representation of the mathematical concept. We have talked about the frame-based representation of a knowledge under our second unit. So AM can create a new concepts or the slots and fill their values in the frame-based system. We have talked about the slots, we have talked about the variables and the functions and the values. So the AM can create new concept slots and the fill in their values here, and the heuristic search employed. What the heuristic search is, we have discussed already. The 250 heuristics represent the hints about the activities that might lead to interesting discoveries. Already we are having the clues here. So how to employ the function, create a new concepts and the generalization, etc. It is a work of a hypothesis approach or a test-based approach, which we have discussed in the explanation-based learning, and the agenda control of a discovery research. So what it discovered? The integers. So AM discovered the integers, the additions, the historical approach of the mathematical multiplication, the prime numbers, the Goldbach congestor, and the maximally divisible numbers here. What are the integers? It is possible to count the elements of this set. We are talking about here the set theory, so it is important or it is possible to count the elements of this set. And this is an image of counting function, the integer, the interesting set in its own right. When we are talking about the addition, the union of the two disjoint sets and their counting function. Multiplication, having discovered addition and the multiplication as a laborious set theoretic operations, more effectively descriptions were simply supplied by hand than the prime numbers, which there is a factorization of the numbers, and the numbers with only one factor were discovered. Goldbach congestor, even numbers can be written as the sum of the two primes, right? So we have seen how the even numbers can be written with the sum of the two primes. Here the example is given like 28 is an even number, which can be a sum of the two primes, the 17 and the 11. Then the maximally divisible numbers, number with as many factors as possible. A number k is maximally divisible is k has more factors than any integer less than k. So 12 has a 6 divisors here, 1, 2, 3, 4, 6, and 12. So these are the maximally divisible numbers. So what the data-driven discovery of the backbone is another technique or the discovery we are talking about here in the 1981. So many discoveries were made from the observing data, and we have discussed about the discovery from the data and the data discovery. Many times we have talked about here in the AI also. So many discoveries are made from generally observing a data and searching a particular pattern in the data and generating the particular pattern from the data. obtaining from the world or from the environment and making sense it, right? So astrophysics, discovery of the planets, quantum mechanism, discovery of the subatomic particles from the data that is already present, from observing that data which has been obtained from the environment or from the world, which can make a sense, which have simply here we are talking about some implicit knowledge is there. And we need to discover a further knowledge from that implicit knowledge, right? The backend is an attempt at providing such an AI system, backend system outline. What do you understand by the backend here? आपने सीरीज में पहले बैकएंड के बारे में और BACON के बारे में सुना है. It is can define a backend as a scientific discovery system, which is basically imposed in a deep learning environment powered by the poetry generator. Or we can say that it's a system designed to discover the mathematical relationships. We are talking about the mathematical relationships and the equations from the data from observing the data, right? So here the purpose of backend, this is a scientific. Backend is here the scientific discovery system to find the relationship between the contents or the multivariable system. Basically, it uses the heuristic-based method to analyze and discover the underlying patterns and the equations. Here, the patterns and the equations are analyzed properly so that the another information or the relationship between the variables or the connection between the data can be generated or the patterns can be searched. So it takes a data as an input which is already present in a system, right? So it takes in data as an input and use a combination of techniques. Whatever techniques are present, it uses the different techniques or the search techniques or the algorithms and including the generalization of the attributes also, so that the attributes can be generalized to form a further output and the prediction of the values also, where we are talking about the heuristic search also to discover the empirical laws. So if we talk about the backend here, the backend is an attempt at providing such an AI system, which is a scientific discovery system, which starts with a set of variables for a problem. What information or the data it is already having, the set of variables for a problem. Example here we are taking, backend has able to drive the ideal gas flow. It started with the four variables P, gas pressure, P stands for the gas pressure, V stands for the gas volume, N stands for the molar mass of a gas, and T stands for the temperature. So with the help of this, it recalls that PV is divided by NP here, where K equal to K is a constant here. So value from the experimental data from the problem are inputted. Back and hold some constants and attempt to notice trends in the data and inferences are necessary. These are the steps which are to be followed by a backend system. So backend has also been applied to the Kepler's third law on slow conservation of the momentum and the Joule's law. If we talk about where it has been applied, so these are the examples here. Or if we say differently others, so whatever the scientific laws or the experiment data we are talking about, we are using here a backend law or the backend has been used to rediscover the ideal gas law or the other scientific laws from the experimental data. Let's move to another slide. Now, what is a clustering? We have talking about the backend. What is a clustering in learning by discovery? What do you understand by a clustering? Yes, clustering involves the grouping data into a several new class. Just grouping the data of group by function here we are using. So what do you understand by the clustering? First, you need to understand this. We are talking about here the learning or the AI clustering here. We are talking about here the AI clustering where we are talking about the unsupervised machine learning algorithms will be used to uncover the hidden patterns and the relationship within the data without the human interference. So the clustering is here basically grouping the similar data which similar data points together, revealing the cluster that represented distinct segments of the categories, right? So the final set of the categories we are talking about here, or the cluster to describe that data. And definitely this process allow for the knowledge discovery. So when we are talking about the clustering of a similar types of a data or clustering of a similar types of a data points together, then the new cluster will get formed with the when the new classes will get formed. So somewhere the distinct or the different knowledge will be get discovered where the insights about the data structure and the relationships are revealed with the help of an automated analysis. So here we are talking about clustering algorithm. So the clustering algorithm basically analyze the data characteristics. What it does, how it works, it analyzes the data characteristics, identify the similarities and the difference between the data points. According to this, it groups the data which have the similarities. So this algorithm basically it works iteratively, grouping the data points into the cluster based on their criteria, whatever the proximity they are having, according to that, according to considering that proximity or the criteria, it will give you the another group of data or the cluster, which is basically a discovery of a new knowledge or the insights of about the data. So the resulting cluster will represent the distinct means the unique group of data points with shared characteristics here and revealing the hidden patterns or the relationships which can be had to generate a new decision making data. So if we talk about the applications, some important application in the cluster, we are talking about the image recognition. Because if you studied about the image recognition in the image analysis, clustering should be done to group the similar pixels or the features together, helping to identify an object or the region of an interest accordingly. Or the particularly text mining. For the text mining also we can use the clustering. Clustering can be used to group the similar documents or the articles if we are talking about any matching between the documents or the articles based on their content. So facilitating the text analysis can be used and the information can be retrieved according to the release data. So what we are talking about here, the clustering involves the grouping the data into the several new classes or in a new data automatically. It is the common descriptive task. It's a descriptive task where one seeks to identify a finite set of categories or the clusters to describe the data. For example, we may want to cluster the houses to find the distribution patterns. So the clustering is the process of grouping a set of physical or the abstract objects also into a class of a similar objects. If we are talking about the abstract objects, you must know what is abstract objects or the physical objects we are talking about here or the devices we are talking about here into the classes of a similar objects. So simply a cluster is a collection of data objects. Cluster is a collection of data objects that are similar to one another within the same cluster and are dissimilar to the objects in the other cluster. So the clustering analysis helps construct the meaningful partitioning of a large set of objects. So the task of clustering is to maximize the intra-class similarity and minimize the inter-class similarity. So given n k-dimensional feature vectors, find a meaningful pattern of the n example into a C subsets or a group. We are talking about where the data or the grouping of a data or the subset of a data. So given n dimensional feature vector, find a meaningful pattern of an example into a C subsets or a groups, discover the labels automatically. C may be given or discovered and much more difficult than classification since in the later the groups are given and we see a compact description. So what is the learning by discovery is here? Again, the autoclass is a clustering algorithm which is based on a Bayesian approach which we have discussed in the last unit for determining the optimal classes in the large data sets. So given a set here, x equal to x1 to xn of the data instances xi with an unknown class, the goal of a Bayesian classification is to Search for the best class description that predicts the data in a model spaces. So the class membership is expressed probabilistically. An instance is not assigned to a unique class, but it has probability expressed as a weight values of belongings to each of our possible classes here. So the auto class calculates what the auto class is doing here. The auto class calculates the likelihood of each instances belonging to each class C and then calculates a set of a weight which is equal to Ci divided by Sj and C to each instance here. Weight statistics relevant, the statistics relevant to each one of a class likelihood are calculated for the estimating the class model. So these are the classification steps, or the classification step is the most computationally intensive here, and it computes the weight of every instant for each class and compute the parameter of a classification. So what do you understand by here in the auto class? Till now, what we have discussed in the auto class? Simply, a auto class clustering is a process where the algorithm automatically group the data, points, or the objects into a distinct classes. What we are doing here, the whatever the data points are grouping according to their similarities, or the objects into distinct classes at the clusters based on their similarities without prior knowledge of a class labels here. So here we are talking about the unsupervised machine learning technique, meaning it does not rely on the mobile data to learn the patterns. So what the approach here we are discussing in the automatic class formation. Instead of manual defining the classes, here we are using the clustering algorithms, which automatically determine the number of a cluster and the data points that belongs to each cluster. So in which task it can be useful? Data exploration. Whatever the data has been represented in the knowledge base, according to the data exploration, it will discovery of a hidden patterns and the structures in the data sets will be there. The pre-processing, splitting the larger data sets into a smaller subsets. Here we are talking about the subsets for the further analyzing. Anomaly detection will be there, identifying the outliers or the unusual data points. Cluster or the customer segmentation can be there, grouping customer based on purchasing behavior or the other characteristics. Image processing can be an application here where the segmenting images into different objects can be there. So we have discussed about the auto class clustering also. So when we are talking about the clustering, the AI can use the different clustering algorithms. You must have learned about the K-means clustering algorithm, or the hierarchically clustering algorithm, or the density-based clustering algorithm, or the mean shift clustering algorithm, right? So all the clustering algorithms are being approached here. Now, what is a formal learning? What do you understand by the formal learning? So, as a topic in the learning, we need to talk about the formal learning. So, what do you understand the formal learning theory, which is basically a theory which provides a mathematical framework, where already the mathematics has been explained here. So, it is based on a mathematical framework for understanding and analyzing the machine learning algorithms here. So it focuses on the process of a learning from the data, identifying the patterns and making the predictions of the decisions. This theory has to formally define learning tasks, analyzing the performance of a different algorithms, understanding the fundamental principles of a learning as a computational process. So definitely here we are talking about theory of a learnable relevant, classifies the problem by how difficult they are to learn. So formally a device can learn a concept if it can, given a positive and the negative examples, produce an algorithm that will classify future examples correctly with the probability 1 divided by h. So the complexity of a learning a function is decided by three factors: the learning or the error tolerance, which is will be shown by the h, the number of binary features represented in the examples represented by t, and the size of a rules necessary to make the discrimination represented by f. So if the number of a training examples is a polynomial in HDF, then the system is said to be trainable. So here the system is already trainable. We are talking about the formal learning is also presented here. Simply here we are talking about it provides a precise mathematical framework for underlying learning tasks and the algorithm. It enables the analysis of the algorithm performances and the identification of a conditions under which the learning is possible. So here, the example we are talking about the learning features description. Mathematical theory will be used to quantify the use of a knowledge here. Example here, we are talking about gray. Something is there. We are talking about if the particular mammal is there, which is gray also, large also, vegetarian also, wild also. We are talking about here the elephant, right? Gray and mammal, vegetarian is not, but the large is here or the wild is here. Again, we can say the elephant. We are saying the gray mammal, not large, but the vegetarian, but the wild is here. We can say the mouse also, right? But the gray is not the gray, but the mammal, but the large, but the vegetarian, but the wild. We can say the giraffe is here. The particular animal which is gray, but not the mammal, not but the large, but not the vegetarian, but the wild. Wild is a dinosaur we are talking about here. And if the particular animal is a gray, mammal, large, and the vegetarian, but not wild, we are talking about here the elephant. So another learning algorithms we need to discuss about the neural networks or the population genetics and the selection of the genetic learning here. So let's move to our another slide where we will discuss about the neural network and the genetic learning algorithms. So if we see the overview of our machine learning or the learning techniques that we have discussed so far, we are talking about the machine learning types, which can be a supervised, unsupervised, or semi-supervised, or the reinforcement learning. Under the supervised learning, we are talking about the continuous target variable or the categorical target variable. When we are seeing the continuous target variable, that is a regression type of a learning, or and the housing price prediction is our application we are talking about here. When we are talking about the categorical target variable, we are talking about the classification, the category wise we are dividing the data. So we are talking about here the application, the medical and imaging. In the unsupervised learning, the target variable not available. No labeling of a data is available. So here we are talking about the clustering or the association, and the clustering we are using for the customer segmentation. Association we are talking about here the market basket analysis. Then in the semi-supervised learning, categorical target variable is present, where we are talking about again the classification, which is working as a text classification. Clustering is a lane finding on the GPS data. Reinforcement learning can also be target variable not available, or the target variable can be available. When we are talking about the target variable is available, sorry, the classification, we are talking about to optimize marketing, and the target variable not available, that means a control. We are talking about a driverless cars.